Okay, a quick summary again. Okay, this section deals with the lines, two lines. So two lines can either be intersecting, two lines can be non-intersecting. So in the case of these are the two cases by which your lines are non-intersecting. Non-intersecting and at the same time non-parallel, they are skew lines. Non-intersecting line can also be parallel lines. Okay, and if the lines are parallel and at the same time intersecting, they are what we call coincident lines. Okay, so this is the section dealing with two lines. So with that, we are moving on to the next section, which we talk about the interactions between line and plane. So again, there are a few possible scenarios. The line is not parallel to the plane. So imagine if a line is not parallel to the plane, to any plane, they surely will intersect at a point. If the line is parallel to a plane, confirm there will be never any intersection point between the line and the plane. And if the line is on the plane, the line will be parallel and at the same time the entire line is on the plane. So these are the three scenarios pertaining to lines and planes. Okay, so again, the whole concept is, when we talk about intersection, the whole idea is always equate everything together. So this time around, let's try now. I'm given the equation of a line here. Then I say that the line is going to intersect this plane. Okay, take note, this is the vector equation form of a line. This is the Cartesian equation of a plane. You need to find for me the points of intersection of the line and the plane. So what you need to do now is basically equate, but then you need to look at what you have. Can you equate everything together? So this is a bit of skill that you need to be asking yourself. Okay, one is in vector equation form, the other one is in Cartesian equation form. Do you have any means to actually equate? This is R, this is X, Y, Z. How to equate? There's no way that you can equate. So this is when your earlier chapters, the skill comes in. You need to change the form of either equation into something that is similar, that's found on both equations, so that you can equate them together. So what I'm going to do now is I'm going to operate on the equation of the plane. This is the Cartesian equation of the plane. I'm going to change it into the R dot n form. Okay, rewriting the equation into R dot n form. Now you see the R appearing. You also have an R in your equation of the line. This time round, you can equate. Okay, substitute this R into this R. Okay, that's what we call equating the two items together. So once you put them together, this is what happens. And of course, your chapter 2 skills come in. How to do your dot product. Okay, activate your dot product here and here, and then you end up with something like this. Okay, it is good that you try and see whether you can generate this equation. And then from here, simplifying everything, you get t equals minus 2. And what to do with this t equals minus 2? Pump back into this equation, and you actually get the point of intersection between the line and the plane. So sometimes question asks for position vector, sometimes question asks for coordinates. So if the question asks for coordinates, give me the answer in coordinate form. Next example, I have given to you 2 points or 2 position vector OA, OB. So the question now is, find the position vector of the line where the line AB is the XY plane. So this kind of question, you need a few more steps. Now, I don't give you the equation directly. So you first thing must find for me the equation of the line AB. Chapter 4 skills have to be activated. How do you write down an equation of a line if I were to give you 2 position vector? So what you need to do, remember to write down the equation line, I need 1 point. Okay, R equals to A plus lambda B. I need 1 point, I need 1 direction. Direction must be AB. The point can be OA or OB. Okay, so write down everything in column vector 1 first. Then find for me AB. This is the direction of the line, direction vector of the line. Then for convenience sake, I use a point OA followed by the direction. This is your equation of the line AB. So going back to the question, I want the point of intersection of the line AB and the XY plane. Okay, so XY plane, what is the equation of the XY plane? So for this, I need you to visualize again. XY plane, where is the normal? The normal is the Z-axis. XY plane, normal is Z-axis. What is the direction of the Z-axis? Is 0, 0, 1. Okay, and that's how I visualize or write down my equation of the XY plane. XY plane passes through the origin, so r dot n equals to a dot n. The a dot n confirm give me the 0 because a, or the point on the plane, is the origin. So what to do next? Now I have found the equation of the plane. I also have found the equation of the line. So your job now is to equate. So how to equate? Put this r into this r, and that's what you get. Thereafter, dot product, solve for your value for s, and what to do next? Pump the s value back inside here. You actually get your point of intersection of the line and plane. Okay, so just remember, not all lines will intersect a plane. If they don't intersect, they 100% must be parallel. Okay, one more example. You have line L, you have plane pi given equation of the line in vector equation form, given the equation of the plane in your r dot n form. This time round, the question asks you to show that the line, okay, this line is parallel to pi. Okay, you need to show for me whether the line is parallel to pi. So let's visualize everything. You need to draw. Okay, if the line is parallel, this is the line, it's parallel to the plane. This is what's going to happen. What I need you to understand is, this is the line. Where is the normal vector of the plane? This is the normal vector of the plane. If the line L is parallel to the plane, the line L is perpendicular to the normal vector of the plane. Okay, one more time. The line must be perpendicular to the normal vector of the plane. Okay, so you see the magic word perpendicular coming out. So when you see perpendicular, dot product from chapter 2, perpendicular dot product must be equals to 0. So who to dot now? I need to take the direction vector of the line. Okay, where is the direction vector of the line? This is the direction vector of the line. Dot with the normal vector of the plane must be 0. Okay, one more time. Direction vector of the line dot with the normal vector of the plane must produce 0. So I run this test. True enough, you get 0. So you conclude very nicely, the line L is perpendicular to the normal of the plane. And if line L is perpendicular to the normal of the plane, the line L must be parallel to the plane pi. That's the first part done. Next job is you need to determine now. Okay, the line is parallel to the plane. Now, is the line actually on the plane itself? So how do I check? Do I have a point from the line? 2, 1, minus 1 is lying on the line. If 2, 1, minus 1 also lie on the plane, then the entire line will lie on the plane. So that's the test that I run. So what to do? I'm going to substitute 2, 1, minus 1 into the equation of the plane. Okay, equation of the plane is here. I'm going to substitute 2, 1, minus 1. Replace r by 2, 1, minus 1. So 2, 1, minus 1, I pump in, I check. Actually, I get minus 3. And it doesn't equal to the equation, or does not equals to 1, because the equation of the plane says that it must be equals to 1. But on the left hand side, I actually get a minus from the operation on the left hand side. I get a minus 3. Does not equals to 1, so it concludes that 2, 1, minus 1 is not on the plane. Okay, it's on the line but not on the plane. So very nicely, the line is 100% parallel to the plane, but the line is not lying on the plane.